So AWS Lambda now supports a custom runtime, and it's a little bit interesting the way that they've done this. If you think about the OpenFaaS architecture, you tend to have an ingress coming into your Kubernetes cluster. A message will come down this pipe to the API gateway, which will listen on a HTTP port. That will then reach across and hit a pod that has a HTTP server in it. That will then run the function. The request body will go in, the request response will come out of that, and it goes back up the wire again. Now, the way that these new custom runtimes have done is a bit different. Actually, what happens is you can basically follow this example that I found this tutorial, and you start a process like a daemon, and that daemon actually has to make a request outbound to a service that will be given. It will be injected this via environmental variable, and you call next, and that will block, and it will block until you get a response. Now, you'll get an ID through HTTP header, but the actual body will come from that as well, and then you need to process that, and once you've processed it, you call back to the same service, and this time you put that request ID that you got in the header back into the URL, and you give your body, and that's that. So this is an example of a shell script. What I've done here is done the same thing in OpenFaaS. So we get this message coming in from the API gateway, hits our watchdog, and for this we'd need some kind of new mode called Lambda, and at the same time we would have forked off a process called Bootstrap, which would look a lot like this, but it would be written in Node. Now that already exists. Amazon have already created that, and the Docker Lambda project have exported it directly from their environment already. But because we've got a little bit of a dance going on here, we can't just take the request and send it onto the function. We have to kind of put it somewhere, if you like, and queue it, and then know basically that this process is going to call back into us, and it's going to say, give me next, and that corresponds to this line of code here. What we'll do is we'll then look and see if we got anything for you. We'll dequeue this request, send it back in the response, and then we still can't give anything back yet because we don't have a response from the Bootstrap code. The next thing is the Bootstrap code will send a response. We have to 202 accept it, and then that response, let's say it said hi OpenFaaS, will come back into this queue or this stateful memory, and then we can actually flush that response back down that HTTP socket to the caller. So at this point in time, we've served the complete request, and the data came in, we queued it, the Bootstrap polled for it, we looked it up, we gave it the message, and then they sent a message back to us, and finally we were able to kill that connection and send a response back. So if this looks complicated, it's because it is. I'm not sure what led to this model. The way OpenFaaS would generally work is we'll get a message will come straight in, our watchdog will pick it up, it will forward it to the code, the function code, and immediately we get a response. So this is a little bit roundabout. What I'm going to show you is there's a GitHub repo that I put together very quickly, and it shows you how to run this locally. You can find this on my personal GitHub account. What we do is we clone down the Docker Node.js runtime, and then we basically give it a few parameters. We tell it where we want it to look up for these requests, and that's going to be our shim, OpenFaaS shim. We'll then clone and run the OpenFaaS shim, which is a Node.js, a Golang application. It has the shim port that talks to the Bootstrap, and it has its own port that would normally talk to the OpenFaaS API gateway. Okay, and then when we invoke this, we're just simply sending a message over to the port 8080, and then that will be held in memory. The Bootstrap that is basically unmodified from what Lambda is using will come along, pick that up, and then process it. So we've got two processes to run here. The first one is we've got some Golang code that basically sits in the middle and would be placed in this OF watchdog, so it's doing that job. The second bit of code is we've got this node Lambda code that's being provided by the Docker Lambda project. So I'm going to run this now, and that's started listening on the 2 TCP ports. The next thing I'm going to do is I'm going to run this Lambda runtime, the bootstrap. Remember, that's going to go back to the next endpoint. It's actually going to block because there'll be no traffic for it. So that's now blocked, waiting for traffic. And up in the top, I have a small tester program written in Node, which is going to go off and call the shim. It's going to input a number, and we get a response back. We check that the number matches what we expected. If it doesn't, we will print that out on the console. So we just type in node index, and we're going to get 100 requests will go in. And what do we see? Well, this is the code that was exported from Lambda. Again, these are all out of sequence because they were done asynchronously from a node client. But we can see the request came in here, input 99. This was what was sent via my tester program. And then an output was produced. We also have a request ID that we can trace through the system. So we should see this in the logs. And what we see is, first of all, they called next. We generated a ID. We took in the body. And so this body would be in effect going up to this step, what we did here. We then saw that when next was called, we served that body, and then we got a response back, which we saved and then let back down the HTTP socket. So this is the full workflow of the data coming in, being handled in the node shim, having the bootstrap, official bootstrap from AWS, come up, pick up that data from the table, return it back down, have it processed, and then get that sent back down the wire. Now, one of the things I wanted to do is to show that you can actually run this in parallel. So if we did it a few times, we'll actually see no errors at all, even with effectively 1, 2, 3, 4 different processes sending 100 requests each. So let's type node instead of vim. So there's 4 processes, and we're going to run them all at once. And we've got the data come in here. We've got all the responses come back as expected. I still had some vim commands there. Right, let's do it again. Okay, so that's effectively 400 of those requests all being processed and echoed back. We take a shim, place that in an OpenFaaS container, and then start processing Lambda functions. The same code that you've written for Lambda, if it's going to run in a custom runtime, can run on OpenFaaS using this technology.